Tensile structures and membrane architecture represent innovative and versatile design approaches in architecture, engineering, and construction. These techniques involve the use of tensioned membranes or fabrics to create lightweight, flexible, and aesthetically pleasing structures. Here's an overview of these concepts. Tensile structures. Tensile structures are architectural forms that utilize tension forces to support loads. Instead of relying on compression like traditional buildings, these structures use elements such as cables, ropes, or fabrics to carry the load. Tensile structures often employ materials like high-strength steel cables, polyester fabrics, or other durable materials. These materials are chosen for their strength, flexibility, and ability to withstand tension. Advantages. Lightweight. Tensile structures are generally lightweight compared to traditional buildings, making them suitable for spanning large areas. Versatility. They can take various forms, including canopies, roofs, domes, and tents, offering flexibility in design. Cost-effective. Tensile structures can be more cost-effective than traditional construction methods, especially for large-span applications. Examples. Tensile canopies, covering outdoor spaces like stadiums or public plazas. Tensile roofs, providing shelter for sports facilities, exhibition spaces, or transportation hubs. Tents and pavilions, temporary or semi-permanent structures for events. Membrane architecture. Membrane architecture refers to the use of flexible membranes, often made of synthetic materials, to create architectural elements. These membranes can be tensioned or inflated to achieve various shapes and forms. Membranes are typically made from materials like PTFE, PVC, or ETFE. These materials offer durability, translucency, and lightweight properties. Advantages. Translucency. Membrane materials can allow diffused natural light, creating visually appealing and energy-efficient spaces. Adaptability. Membrane structures can adapt to different shapes and sizes, allowing for creative and innovative designs. Quick installation. Membrane structures can be erected relatively quickly compared to traditional construction methods. Examples. Air-supported structures. Inflatable structures like sports domes or temporary pavilions. ETFE roofs. Ethylene tetrafluoroethylene cushions used in roofing for natural light. Tensile membrane facades. Facades made of tensioned membranes for aesthetic and functional purposes. Common applications. Stadiums and sports facilities. Tensile structures are often used to create large-span roofs for sports arenas. Exhibition spaces. Membrane architecture is well-suited for temporary pavilions and exhibition spaces due to its quick assembly and striking aesthetics. Commercial spaces. Tensile structures can provide unique and visually appealing solutions for commercial buildings, especially in creating covered outdoor areas. Public spaces. Both tensile structures and membrane architecture are employed to create engaging and functional public spaces, such as plazas, transit stations, and cultural venues. In summary, tensile structures and membrane architecture showcase the marriage of engineering and design innovation, offering solutions for a wide range of architectural and construction challenges. These techniques continue to evolve, pushing the boundaries of what's possible in contemporary architecture.